Hi, I'm Louis Lenz. I'm an application engineer here at Engineered Seal Products. And today I would like to go over an intro to radial shaft seals. Specifically, I would like to discuss the application details of what the customer's parameters might be, the envelope in which the seal is going to go into, and then some common lip profiles here that we typically recommend. So starting off, the first thing that we will typically get from the customer is the size. So this might be, how big is your shaft? How big is your bore? What's the width that the seal is going to actually fit into? These are very important because our engineering design guide kind of revolves around this. On top of that, we also have temperature. We need to know what's the low temperature, what's the high temperature. This is very important for the material selection. We want to make sure we get a good material in there where the seal is going to be able to flex, and at colder temperatures we don't run into a really hard material. As well as on the high end, we don't run into a material that just starts getting eaten away. This kind of falls into fluid. We need to pick a material that works well with the fluid. So whether it's grease or an oil, we need to make sure that the material is compatible with the fluid. Another part of that is debris. We need to know if we're trying to keep debris out of the system. This typically utilizes a dust slip on the seal, but we can get into more complex profiles based on how much debris that you think your system is going to see. Another parameter that affects sealability is your pressure. Specifically, we don't really like a lot of pressure in the system. We typically recommend about 7 psi as a max, so this is a very low pressure seal that we recommend. Another parameter is the motion. So is the seal going to be rotating? Is it going to be reciprocating? Is it going to be oscillating? These are all parameters that we need to know, as well as the shaft speed. Shaft speed kind of goes along with temperature. We want to know what the underlip temperature is going to be based off of how fast that shaft is rotating and the friction generated, and will be important for selecting the right material as well. Finally, we have a design action request form that kind of captures all of these parameters. So feel free to reach out and we can get that form over to you. Now, specifically for the envelope, for the shaft, we typically recommend a Rockwell hardness of C30, where the material is a carbon steel. And typically we recommend a 30-degree chamfer angle at varied lengths based off of how big the shaft size is. And for your bore, we typically recommend steel and cast irons. The reason for this is thermal expansion, and we want to try to make sure that we're not going to be growing the material. And so the chamfer that we recommend is 15 to 30 degrees, where it kind of varies from 1.5 millimeters to 2.2 millimeters. Let's kind of move on to common lip profiles. The most used common lip profile is going to be your oil seal right here. Specifically, it's used to try to keep oil on this side of the system, and you don't want oil to leak out of the system. So it's utilizing this garter spring here to just kind of help push down on the shaft. Now let's say you have contamination that you're trying to keep out. So this is where you're going to kind of utilize a dust lip. This seal profile here can also utilize a garter spring, but just for general purposes, you're trying to keep contamination from entering the system, and you're trying to prevent fluid from exiting the system. These are typically used more for oil. You could utilize grease in these, but because you're trying to trap oil from the inside, then it's more common to go with maybe a seal like this, a multi-lip seal. It's more for contamination and keeping debris out. Just kind of utilizes each lip in order to prevent anything from getting into the system. As well as an oil separating seal. You typically have, let's say you have two different places where you're trying to prevent the oil from mixing together. So it's utilizing the garter spring to keep it on each side respectively. Each of these seals kind of typically run on either some kind of oil film or really need to utilize lubrication. If not, you can cause the seals to burn out very easy, so we recommend that you don't run in a dry system. Whether that be oil or grease, we recommend some kind of lubrication. Now for some common bore types, we have your typical can that's going to go on your bore. This is just to kind of help the structure of the seal to stay in place. You typically utilize OD paint on the OD of it right here, and that's just to make sure that it helps with the sealability. Any imperfections from the steel or cast iron is going to kind of be covered up by the OD paint. Now, if the steel or cast iron has way too much and the OD paint isn't really going to cut it, then we recommend a rubber covered seal. This kind of helps utilize rubber to seal from the OD, but the biggest issue with this is spring back, and the seals might have the opportunity to kind of push out once you install them. From here we have a heel case, and this kind of utilizes your rubber portion and your can portion, so it helps with the structure, and it's utilizing the can to help with installation, but then it's also utilizing the rubber portion to kind of help with sealability on the OD. And we also have a double case, and this is kind of more for bigger profiles, and it's just kind of to help the structure of the seal stay in place. The only one profile that's not on here that I'd also like to talk about is probably a shotgun style seal. It's utilizing a can, but it's kind of flanged up like this, and it's to help with installation, ease of removal. It just kind of puts the seal in place. So that's a very common one as well. So like I said, this is just kind of an overview of common lip profiles, common bore profiles, and what we kind of try to see and get from you just to understand the application that you're providing. And feel free to reach out with any questions or concerns you may have, and we'd be happy to go over the design action request form with you.